Okay, in this example, we are finding the moment of the 100 Newton force about various points. Okay, so this is the force. And the first point we look at is A. Right? So the moment of the force about point A will be the force multiplied by a perpendicular distance. Okay, so in this case, this is the line of action of the force. Okay? The line of action. And the perpendicular distance will be this distance. Okay, which you can see is 4 meters. Right? And this is a clockwise moment. Okay? So the answer here is 400 Newton meter, and we just simply put a direction clockwise, okay, to denote the direction of this moment. Okay, now let's move on to point B. So if we are looking at point B, okay, the distance would now be 2 meters. So we have 100 times 2, which is 200. And again, it's a clockwise moment. Now, if you're wondering, okay, how to figure out that direction, okay, you may want to simply consider, okay, the point B as a center of a circle and trying to draw the circle with a 2 meter radius, okay, and using a compasses, and it's going to swing this way. Okay, so that makes it clockwise. Right. Now let's look at another point, C. So if the point is at C, okay, the distance would now, okay, still be 2 meters. So it's 100 times 2, you get 200. And this time it's going anti-clockwise. So, okay, we put a symbol anti-clockwise. Okay, finally, okay, let's move on to look at one last point, which is at D. Now, so D is here. Okay, I'm deliberately making this point big. Okay, now, the moment of this force, okay, about this point, okay, in this case, okay, will be equal to 0. The reason being that the point, okay, is lying along the line of action of the force. Okay, so you may want to just put 100 times naught, okay, no distance, you get naught. Okay, so this is how it is, all right, for point D. Okay, let's move on to the next example. Okay, in this next example, okay, we are given the 100 Newton force, which is 30 degrees off the vertical. Okay, now there are two ways to go about doing this problem. Okay, the first way that we can do is by looking at the original force given, okay, which is the 200 newtons. Okay, and this is recommended as an alternative solution. Okay, now based on the concept of the definition of moment, it's force times distance. Okay, now in this case, okay, the perpendicular distance is not obvious for the 100 Newton force, okay, because this is not a perpendicular angle. This is 120 degrees. Okay, so you cannot, when we find the moment of point A, okay, you cannot take 100 multiplied by the distance 4. Okay, because that distance 4, which is distance AD, is not perpendicular to the line of action of the force. Alright? So what you have to do is, if we have to if we are going to use the 100 newtons, okay, then you will need to work out that perpendicular distance. And how do we figure that out? Okay, you do that by producing the line of action of the given force, and then from the point A, okay, you drop a perpendicular distance, a 90-degree distance, okay, to that line of action of the force. And that distance is dA, which is perpendicular distance. And you will need to calculate this perpendicular distance, all right, to be able to find the moment about point A this way. Now, is there another way which is more effective, which is quicker, okay, which doesn't involve you having to calculate a perpendicular distance? The answer is yes. Okay, and let me show you how that's done. Okay, in figure B. Okay, so in figure B, okay, we are doing the same problem, okay, but we're going to do it in a different way. Okay, now, if we were to resolve the 100 newtons, okay, in two components, then our vertical component is 100 cos 30, our horizontal component will be 100 sin 30. All right? So like the earlier example, okay, if you are going to find moments about point A, okay, now we simply consider, instead of the original force 100 newtons, we consider the moment due to its both components. So we have 100 cos 30 times that distance, 4 meters. Okay, and this is a clockwise moment. Okay. And next, we also have to consider the moment due to its other component, 100 sin 30. Now, what would that perpendicular distance be? Okay, if you are thinking that it's equal to nothing, you are correct. Okay, simply because if you were to produce the line of action of this component, it passes through point A. So point A, the point you take moments, lies along the line of action of the force. So definitely there will be no perpendicular distance. Okay, so this gives us an answer 346.4, okay, Newton meter, and it is clockwise. Okay, move on to the second point. If it is a point B, okay, it will be 100 cos 30 times 2 meters. And then again, point B is lying along the line of action of this component, the horizontal component. So again, there will be no perpendicular distance, okay? (173.2 Newton meter). Okay, and the moment is still clockwise. And if the point is at C, here, okay, it is still 2 meters, okay, for the vertical component, okay, and point C again lies along the line of action of that 100 sin 30, so there's no moment for that component, okay, and we get exactly same answer, but this is going to be a anti-clockwise moment. All right? Okay, now let's move on to the last point, point D. Okay, now just by looking at the point, okay, we know that the components pass through this point D. So naturally, there will be no moment for both the components. We just put a knot. Okay, and that's all for this example. Okay, we'll see you the next time.